All right.
What was that?
All right, my friends. I have a handout for you, but I'm going to hole punch it because I like you.
Then place virtual reality. Mr. F-Man, did you need to put a yet at the end of that?
What?
Like, you like us yet.
What? That was over text.
Oh, yeah.
Yeah. Looks that wall confusingly.
By the way, in case this wasn't like kind of something you would infer on your own, especially with how small we are, if you guys want to like rotate desks or whatever to face differently, you can.
I don't want to put them back.
Well, yeah, that's the only thing is then you got to put it back. I do have a lot of revisions from you guys. I am getting through those and getting grades updated. I hope to get you guys things back tomorrow. I went to Kazakh over the weekend and didn't really do much schoolwork because sometimes you just need to take a break.
Can we take a break today from
No, but I'll try to make it fast so then you guys can have time to work on your practice. So, I had said that we would have the same homework on Monday. What it really comes down to when looking at the homework from Friday, wherever my book is. So, I'm really not going to go through and count how many of these questions you did. But what this is looking for is, can you do compound events, right? One, then the other. Can we multiply a binomial by a binomial, whether we use area model or whatever we use? This is where most of us are screwing up and where we screwed up on the test.
You just take it time.
This is not 16x minus 1.
Yeah, you gotta.
I know. Squared.
I know. You gotta like.
I'm trying to be quick. I'm sorry. This is 4x minus 1 times 4x minus 1. There's a middle term you need to think about. That is just x to the first power. Richard, you need a handout. So, then on 57, can you draw a shape given certain vertices and calculate? So, do I think you can put points on a graph? Yeah. The thing I was looking for there, hey guys, I don't know why I keep having to compete with people talking, but you know, I paid like $100,000 for my education. So, I think you might want to listen to me. Maybe. And if not, I don't even have a door, so peace. It's this. Guys, I'm trying to go through and pinpoint what you should have cared about and what you could skip if you didn't do it yet. This is really asking, can you deal with the distance formula of non-straight lines, like non-horizontal or vertical lines? So if you need to look up the distance formula, look it up. It's pretty much a manipulation of the Pythagorean theorem. And by pretty much, I mean it is. Satya.
Is there an easier way to find out the distance other than
No. I mean,
Pythagorean, and
so the easier way is don't think about the Pythagorean. Think about the square root of the sum of the squares.
That's Pythagorean.
Yes, but don't think it through the way that we set up the Pythagorean, like a squared plus b squared equals c squared. If you know the horizontal and vertical lengths, square, add it, and then take the square root.
Why are we still doing Pythagorean?
Because it was his. He any manipulation of it still traces back to Pythagorean.
No, but like why are
Because
we
it's one
still
of the
using
most
it?
efficient
Because we know
skills
how
that
to.
we
Satya,
why are we still using it?
Okay, Satya, what's the third leg of a right triangle with legs of 8 and 17?
I don't know all the perfect.
Does your brain have a shortcut that avoids the Pythagorean?
No.
Then that's why we're still using it.
No, I mean like why do we still
Thanks.
go to questions like this every single homework?
Because I guarantee if I gave you 5, you'd get one wrong.
Yeah, probably. That's like
Stop
every
you.
question.
You are not mastered in every part of utilization of the Pythagorean. I bet you if I gave you 2 legs of just a right triangle and they were simple numbers to work with, you'd be fine. But when I give you an octagon and I ask you to figure out the perimeter or things like that, different utilizations. Oh, yeah, you're good. Always, man. And in here, we've got the fancy calculators anyways. Yeah, and just the rest of some of these are review and some of these are like, again, like how much of the circle is it including? So it's just checking a variety of skills. That's why I thought this homework was actually pretty beneficial. If you're real good with these diamond problems, sure, skip that. But like one has a negative, one has a partial, so different things like that. if you're real good at these triangles, you can skip that. But like this is trying to get you to say, okay, 2x plus 82 actually equals 180. Or 71, 71, and x. It's that application of isosceles knowledge.
On both tests, I knew that they were isosceles. I even wrote them down. But on both tests, I wrote log, like side 1 plus side 2 equals 180.
So, you know when you just asked a couple minutes ago, why are we still practicing this?
Yeah.
This is why side.
I just forgot about angle 3.
Alright, so, all of that to say, whatever you did from that homework, great. If you do not want to do any more of it, that's your prerogative. But it's a really good review for things that you're going to see on mastery assessments coming soon. So today, we're going to move on to the 3-2-1 and hopefully have time for some homework because trig is like one understanding. Like, and once you get that understanding, you know trig. If you want to take this further, if you start to get really interested in trig, I will tell you, one of my favorite college classes, one of my intro courses, but college algebra and trigonometry. Algebra is like a lot of what we've been doing. They used to, back in the day, split algebra and geometry very distinctly. Like you wouldn't do the geometric stuff in your algebra course. You'd wait till the next year, which we've now discovered, like, that's not a good idea. Like, teach them together because they're related topics. So if you want to practice some of this stuff or just look at more of it, you can borrow this book. I just like to make a note of who has it. That was one of those cases when you buy a book for college and you spend like $100 and some on it and you take it back to sell it back and they're like, yeah, we'll give you 19. And you're like, no. Like, yeah, it's worth more to sit on my bookshelf and me to be able to use whatever I want to than it would be to sell back to you for like pennies on the dollar. So trigonometry. What is trig?
Something we don't really...
Slope.
Oh.
Trig is using a slope relationship to determine degrees. So trig is our connection that takes us from being able to say what's your rise and what's your run to being able to say what's your angle of elevation or angle of declination. So in previous chapters we looked for relationships between triangles and ways to determine if they were similar or congruent. Now we're focusing on the slope triangle, so we have to set up a horizontal and a vertical and then a pivot point, obviously, somewhere that we're going to look at that as the angle. So are these geometric patterns within slope triangles themselves that you can use to answer the questions? In this lesson, we'll look closely at slope triangles on different lines to explore their patterns. So our Leaning Tower of Pisa. Excuse me, you've probably seen lots of pictures, or maybe you haven't seen it. If you Google it, immediately you'll find pictures where people are like, and they're trying to look like they're holding it up. Because if you match in perspective where the tower is to you, it can actually look pretty darn good, like you are holding up the Leaning Tower of Pisa. So, now engineers watch this very, very closely. They've actually done some stuff around the base of it. I think now they might have like a couple support cables or something like that. But we're pretty sure it's stopped. Like I'm almost certain. I mean, you can look this up if you want to prove me wrong or whatever, but I think it went so far and just, it kind of settled because ground can settle. I mean, let's be honest, that's a really big tower with a really small footprint, right? The size at the base. So you're putting a lot of weight in a small amount of area, a lot of PSI, right? Pounds per square inch. Or over there, they probably use square centimeter or something like that. So in the 1100s, get your brain around this. In the 1100s, almost 1,000 years ago, it started to tip. And it's fine. Like, almost 1,000 years later, it's fine. Like, it's tipped, but it's fine. So engineers are like, well, shoot, let's figure out how far this has actually angled itself. Because, right, when it was built, it should have been 90-degree angle, right? Vertical, perpendicular to the ground. So they go out and they actually, this is real, like, so one of the things I really like about CPM is it's not Joe has 72 watermelons. It's we calculate, we have, hey, I get it, we've all seen those memes, right? I get it. What I like is because they want you to actually care about the mathematics. Their data they present is as close to accurate as possible. So 5 meters might be rounded, but this is like legitimate. If you go 5 meters, right? So like think about 5 yards on a football field, about that far. So probably from you to the fan, maybe even further. So if the base of the tower is over at that fan, I'm standing here, the top of the tower is above me.
Oh, I don't like that. I don't like that.
Right. So think about now. Now it's above me 50 meters up. So from like the goal post, not the end zone, but the goal post out to the 50-yard line, that's about 50 meters. Where you got to add on some extra to get to that goal post. So that's sketchy, right? Like that would seem sketchy. I think they don't let people go up anymore because that would seem obviously dangerous. So we need to figure out this angle of slant. So with the measurements provided, what can we determine? Can we determine the angle at which the tower leans? What do you guys think? So work with your groups. I don't want questions. I'm not going to engage with you for a minute. Can you start to kind of try to figure out, make predictions for what you think, how many degrees it has angled? So if we're trying to determine that angle there, how does it?
Wait, that angle?
Does that say 90 degrees?
This is, so I was standing 5 meters away. I looked straight up, and there's the top of the tower. Right, so I've created a right triangle.
Which angle? Okay.
This is right. Where I'm standing looks straight up, and that's the top of the tower. But I am 5 meters away from the tower. This angle right here is not 90 because the tower's tipped.
So we're trying to find that.
We're trying to find this angle, not the 90. Obviously, we know the 90 is 90.
So it's just like
Or if you find this angle, you know this angle, right?
Yeah.
Really basic trigonometry.
This is really basic trigonometry.
This is trigonometry.
Now, if you understood trig, you have your answer. So once you understand trig,
It's like the sin, cosine.
It's sine, cosine, and tangent. Anyway, so I think what we have to do is,
I did a little bit. I only looked at like
Okay, so we've got
we need to
an
find
angle and we've got a side, and then we want the adjacent angle.
So it's like that one.
It's one of the
It should
three.
be lower than
And
that.
it should be lower than
I think it's 60. I think it's 60. I'm thinking it's 60.
How did you get 60, Satya?
That looks like 60.
Satya.
And that looks like
Satya, okay, so look at this. It says that if a leaning tower ever falls below 83 degrees, it will probably collapse. So it can't be 60, you have to be on the ground.
Alright, so it's above 80.
Let me just tell you that.
We know that. So it's probably
I don't
50
look
divided by
at
okay,
it.
it's from 83 to 90.
it's from 83 to 90. It can't be
But
90.
it can't be 80.
It can't be 90.
So it's not
if we have time at the end, there's a couple decent YouTube videos I can show you guys about this.
So place your
25.
bets.
I bet it's 85.
87, bet money.
87.
I don't think it's right here.
Okay.
Okay.
Hypotenuse is like 50. It's 55 meters. Congratulations.
You have to know it, like,
Anyway.
sometimes
This?
you'll raise your hand a certain way, like, and say,
Try to stay on task, please.
that's 90.
Sine?
That's just right side and then put it in the
Put it in red and stuff like right. I hope it works.
Here, I'll grab it. So what's the hypotenuse?
50.2.
What if we ask about the slope? Like, what if I imagine layering
Well, it's 50.
an XY axis here?
Yeah, so
Right.
it's 10.
I've got an idea.
So if I put this point somewhere and then this point, my slope, right, 50 over 5, my slope factor is 10.
No, it's not that easy. You're close. You're very close.
Sine, cosine, tan.
But
No, you're
now wait, hold on. How does a slope of 10, oh, I just called the office, relate to getting to my degree measure? It's a slope of 10 what? It's not 10 degrees.
Wait, you sign it?
Thomas?
Is it 10 divided by tangent, or m?
What do you mean tangent? What are you talking about? You don't know. I don't. There's some buttons on there. I just thought they were words I couldn't read.
There's some cool
Satya?
Okay, I just have a random question. So I messed around with sine, cosine, and tan. So I wrote sine, cosine, tan, 17. Then I wrote tan 17. And they have the same, hold on. Sine, cosine, tan, 1.
Can I
and then
pause you for a
tan
moment?
1.
Aside from relationships that you found interesting, is this going to help us with this problem?
No.
Okay, let's move on. We might come back to the interesting relationships you found, but we're not using those buttons yet. We didn't even I didn't even say use a calculator, right? We're just looking at this.
Oh, we didn't know that.
84.
How'd you get 84?
How'd you get it?
10 times the cosine of 10 minutes of the first two decimal places.
What?
So you have no idea what you did. Thomas?
It's the Toa, so we.
Dude, I don't know what you're talking about. You're making up words.
It's 10 divided by 10.
No, but that's
You can't do 10 divided
No,
by
wait.
It would be 10 tan.
What if?
Or tangent.
What if this was like an isosceles right triangle? 5 and 5, right? That'd be 45. That's one relationship we know. A 5 and a 5 makes 45. Okay. So if my legs are the same, I get 45. Are there any other relationships I could figure out and know for sure?
Equilateral.
Yeah, or even with an isosceles, what could I do to take an equilateral or an isosceles triangle, make a right triangle relationship so I can determine this?
Cut it in half.
Drop in altitude, right? Cut in half. I wonder if there's some stuff we could do here.
So we
You
multiply that by 10 and then
You could
Well, the problem is 45 times 10. But
No.
That's not going to work. So let's look here at one that we've been given. We might come back to Pisa, but right now we don't have enough knowledge to figure that out.
knowledge.
You should be hungry for more knowledge.
Oh, I know what it is.
I need some
You
knowledge.
multiply the bottom wedge by the first one, then add 6.
If you could stop panicking, that would be joy.
So we have this given to us, right? We might as well read what we have. So in order to determine our leaning tower Pisa, we need to investigate this relationship between angles and the side lengths of a right triangle. We'll start by studying our slope triangles that we already know. So let's set up somewhere here that we know it with a rise of 1 and a run of 5. So my slope ratio, right, is 1 to 5, 1/5. And this ends up being approximately, sorry, I should really do like a squiggly equals because it's not exactly 11, but it's darn close. So conversely, does that mean that a slope of 2 to 5 could be determined? Or what about a slope of 1 to 10? Because if I try to relate what we've been given to the Leaning Tower of Pisa, I have a 1/10 relationship, right? We already kind of talked about that.
Mm-hmm.
And if I don't like how the Leaning Tower of Pisa is, could I turn the tower and just say all right, well, instead of looking at it like this, I'm going to look at it like this. Because now, instead of my line having such a crazy slope, I could instead flip that triangle around and make it rise gradually and have a rise of 5 and a run of 50. So I want you and your team to talk for a minute and see if we know this, right? If this is presented to us, is there a way that we could create some more triangles and manipulate this to figure this out in a different way?
Oh, 5 degrees. Okay, so you know that 110?
You can't just call stuff like
Yeah, you
that.
can't just he dies at the end.
Okay, so you know that maybe you triangle is 110, and you know that 150 equals 11. So to get 1/5 into 1/10, you multiply the denominator by 2. You multiply the denominator by 2. So you divide by 2, and you get 5.2. So 1/10.
Now, Satya, let me poke a hole in that.
Please don't.
What if your slope then is 5 over 5?
5 over 5.
What type of triangle would that be?
1, that would be.
The slope is 1.
If I make this 5 over 5,
Oh, that'd be a right triangle.
well, yes, but what's the angle of it?
90.
No, here.
Oh, that's 45. 40. Yeah.
You just said though it's 55?
Please.
Satya is just like,
Okay, I want to get it out.
Alright.
Satya, this is on purpose.
well, actually, hold on.
You're taking the road that I meant for you to take, and you're hitting the roadblock I meant for you to
It's a
hit.
trap.
It's a
No,
trap.
it's a triangle. It's not a trapezoid.
Stop.
We could make it a trapezoid.
Just throw the
You
road
have
back.
chalk. You have chalk.
stock manufacturing.
I mean, some, a variety.
Can I borrow some word card?
No, are you gonna throw it?
Sure, no. I just want to make.
So, this whole manipulation of forcing this to work with the Leaning Tower of Pisa, that may not be the best idea. But, if we want to make sure that we observe something that is true, right, because we're trying to make things up and we're not sure that they're true, and we keep hitting, what if I go all the way out to here, and I make that triangle?
Same angle.
Still 11.
What's my slope?
They're similar.
Well, 1, 2, 3, 4, 5. Ooh, 5.
525.
1, 2, 3, 4, 5, 6, 7, 8.
It's like it's this five splitter thing.
What?
What? That's similar.
Oh,
Yeah, they're similar, so the angles are the same.
so this is still 11 degrees? Yeah, because reduced to, oh, yeah, of course. Because, I mean, like side splitter or hinge theorem or whatever we want to, like, manipulate and pull in and say, it's like, yeah. I mean, right? We would do. So this creates some rules. And,
Don't talk about
What?
okay, I was debating,
You want us to suffer?
well, how much I want to suffer, because now you guys will ask, like, a bajillion questions and you want to utilize this stuff in other ways. So what all trig, no, don't capture that. What all trig comes back to is this thing called the unit circle. Now, when we really talk about the unit circle, we have, hypothetically, an axis system and a circle on it. Maybe I should know. That should be centered.
yeah.
Now, what we really care about in that unit circle is one corner, where we have leg of one, and a whole lot of relationships.
It's a semicircle.
Depending on what your x is versus what your y is going to determine your slope. Right? So if I set up here that my 1 lifts up and goes to here, then this is still 1. Okay, we're freaking out.
Oh, it's like
So my smartboard just like lost consciousness or something.
So you
So
know how
hey, be nice. As we lift in the unit circle, I just want you guys to know, so like if you're interested, you can go start exploring on your own. As we lift up in the unit circle, the hypotenuse always stays 1. What we care about is the length of the y value and the length of the x value, which will now not be 1, right? Because the hypotenuse keeps the 1. So, and we're gonna get here later. I just like to introduce like how these things relate together. I graduated high school not understanding how the unit circle related to trigonometry. It was not until college that I actually had that like, what? Like I was mad. Because if I had understood how the unit circle actually relates to trigonometry, this only works up to 90 degrees, right? But then it reflects in every other region of the unit circle, and for any degree ever, we can apply the unit circle knowledge. So this is where we're headed,
So
is
how do we apply
to understand trig. Like eventually we're going to relate in that it all comes back to the unit circle.
Can we relate it now so that we understand it when the homework comes?
Yeah.
Okay,
Yeah,
good.
I mean,
So if we don't get it now, we're not going to graduate? What?
no, not at all.
Is that where this is going?
I'm dropping out this. I know this, and then
I know how to knowledge to graduate high school.
We're gonna skip 69. 69 essentially is us creating proportional triangles, right? The similar triangles of if I make my y, my rise 60, right? I showed a rise of 5, but if I keep going up my line, gentlemen, can we please grow up?
I don't think they will.
You want me to go get Miss Smith?
It's not
And we have that conversation
Yeah.
of why my immature 8th graders are laughing and can't handle a number?
It's so Chris. It's cool boy
I
like
think he's still laughing about how we're coming elbow someone in the neck.
I just, okay, I was like this, and then I elbowed someone like straight in the neck.
Okay, in 70, we start to think about these relationships like we had for linear graphs. Right? So what if I had the line y equals 2/5 x? Well, we know, okay, that slope's 2/5. Right? But that doesn't mean that it's only 2 by 5. Right? It means that triangle, when I reduce it down, the slope is 2/5. So on your paper, let's go ahead and set up some lines. So on graph A, which I think is the graph that has the 11-degree angle, is that A?
Yeah.
Sorry, so on graph A, yeah, so go ahead and move on to the new one. On graph A, set up your line, slope of 2/5, and just extend it out. Don't just do it for triangle 2 and 5, extend it on out. If you need a ruler, grab one. On graph B, you're going to need a protractor. We're going to make QPR, so P being the vertex.
How big should we extend it out?
Just like across the graph, pretty much, maybe if you're able to. So like 410 or 820. And then on graph C, graph X plus 4. I'm going to give you guys some time to get this taken care of.
This is a 410 dimension, and we don't know how to use one of these.
How probably.
We never learned this.
Okay.
Place the vertex in the center dot at the bottom.
And then just
Line up your flat with your 0.
thank you.
And then find your 18, mark it, and then extend it. Like
I
that.
have math knuckles. Mr. Hudson, I have math knuckles. He's gonna beat you.
I'd much rather you do it.
Not you. Probably me. I'm going to beat my board. What? So funny.
If we allow what Satya was trying to say to be true, which we don't necessarily know that what he was saying was false, we just found a situation where it fell apart. But if we compare graph A to graph 68 or whatever, I wish it had a letter, this is twice as steep.
Let's call it M.
So if we kind of just apply general math knowledge, what Satya said could be pretty darn close to true. This angle is likely close to 22 degrees.
Wait.
Now, we don't know for sure, but probably close. Because we know that when M was 1/5, this created about an 11-degree relationship. So if we take what Satya was trying to say, right, approximately, gravity.
Gravity works.
So then, if you use your protractor, which to do that, line up your your center point here, line up your 0 somewhere, like it's got to be on this line, right? Your 0 point out there. Then go up your protractor till you find your 18, mark it, and then draw that line. So if you're struggling with the protractor, please call me over. So hold on.
I'm struggling with life.
Not at the top, not at the bottom. Now you're upside down because you can't read the numbers. Now we can read the numbers. So 0, and that's your 0 line, which also says 180. But so we start at the low end of the numbers, right? Not 170. We're gonna start with 10. So go till it says 18. We're gonna mark right where it looks like 18. Now that's a 15. So where you have marked is closer to 15. So you want to be right about probably there. Does that make sense? Then, and I just normally use the protractor to do this, use the flat side, line up P with the mark that you made, and then make it. What is the actual slope ratio for 18 degrees? Don't just shout it out. Take a moment to do it if you haven't yet.
Will we have to on test like memorize every single like?
No, because you'll learn how to use the skill. Once you know the skill, it's just like a couple button presses in your calculator. Does it all for you. Huh? No! That's cheating.
Like throw the roadblock at us and just end this. Stop waiting for
Drop-
That's like going to a fisherman and saying, look, I don't need to know how to fish. Just give me a fish. I just want to eat for today.
Yeah, me too.
Yeah.
And then tomorrow, you're starving
And
again.
then go over to the
Fish
fisherman and
needs
say,
for
give
one
me
day.
another
It's
fish.
hard.
But then the fisherman disappears.
Yeah, but they have that
Well,
on
well,
the
you're
Grab
not.
the fishing rod.
That's
for
you,
one day.
though.
Yeah.
Teach a man to
Teach
fish.
you a fish.
It's an old parable.
Teach a man to fish. Teach a man to fish. Teach a man to steal. He can go to place on. Teach a man to fish.
I feel like you don't get metaphor.
Teach a man to pick up.
You should approximately be getting a slope of about 1/3.
I got 1/5.
You failed.
No, I got
If you're
1/3.
18 degrees, I was about to say, be careful with how you're 18 degrees. You might have gotten a rise of 5, but a run of 15. Is that what you have?
Oh, I said that handwriting. I can't even read my handwriting.
And in C,
Yes. Then what was that?
No.
C's graphing x plus 4.
Okay, so yeah. X plus 4. Yeah. Wait, what does that make a trapezoid? Like, not even. Yeah, that'll make a trapezoid.
What do you?
It's a
So, the only reason they have you do this is to remind you of how to draw a slope triangle. You do not need, I'm not zoomed at all, you do not need the values to be on the axis to draw a slope triangle. If I'm asked to draw x plus 4, we start here, right, and we go up by 1. But if I'm asked to draw a slope triangle for this,
Yeah.
you just go from wherever you have it, horizontal,
Oh,
vertical.
I just took the end of the line and then put it down.
Right, that's the reason we're going over this one, is to draw your slope triangle. You want to find just your horizontal, just your vertical. So, however many this is however many this is, right? So, M is just 1. So, when M is 1, you know, a situation like, I don't know, 5 over 5, 6 over 6,
And I saw.
this is a degree measure, 45. And we can start to kind of like make an organized table of these things. And say, how does rise and run compare to our angle measure? And once we start to catalog and kind of organize all these tables, we can create some conjectures. Right? So I got about 5 minutes left, and we're going to test out some conjectures. So let's say, after all this cataloging, after all this documenting, we now say, well, we want to make some conjectures. So we have these. Students in Mrs. Coiner's class make these conjectures. All slope triangles have a ratio of 1/5. If the slope triangle is 1/5, slope angle is approximately 11. If the triangle is an 11-degree slope angle, then the slope ratio is approximately 1/5, and different lines will have different slope angles and different slope ratios. Take 30 seconds with your team to determine which of those are true or false, potentially why. We'll come back together.
Top one's true, everything else false.
First one is false. Second one
Is
is
true. Third one is
Third one is
true.
And
None?
and
Yes.
the fourth one is true.
I'm trying to find
So
out.
everything is true except for the first one.
So then not everything.
Yeah. Ooh, look, me and my siblings.
So, as our group so not quietly discuss, everything here seems true except for the top one.
Yes.
Right, because all slope triangles, that's a pretty broad statement, right? All slope triangles. Let's look at this math notes box. Oh, look, this math notes box is expected value. So one thing that I want to get you guys used to with CPM, if you are working on something and you have not yet gained that knowledge, CPM does that on purpose, right? They want you to be hungry, but they don't just straight up give you the food right when you need it. They make you wait a little bit longer and get a little bit more hungry, so that when they give it to you,
You're more thankful.
yeah, you care about it. So here in the next lesson, tomorrow we'll talk about slope and angle notation. And then the next lesson after that,
Too many lessons.
sorry, there is no math notes box.
There it is.
Slope ratios and angles.
Where you just
So now check it. We did all of these today.
Yeah.
All of this knowledge here we did in class today.
Yeah.
The 1/5 makes approximately 11. Then if you double that, we're assuming approximately 22. 1/3 gives us 18. 3/3 or 5/5, if we really want to like compare things, gives us 45. We can start to kind of organize these and group them together. Come 3 to 5. We talk about the tangent ratio. So, because I like you guys, let's talk about the tangent ratio really quickly. If you are looking for this, this is in the last math notes box of this chapter. The tangent ratio comes from the unit circle. So everybody on your notes paper somewhere, write tangent ratio, please. TOA. As many of you have heard, and don't necessarily know why, there's a phrase in math you hear quite often called SOHCAHTOA. Now, we don't care about SOHCA right now. We just care about tangent. So, TOA actually means the tangent of an angle theta, yes, it looks like an Easter egg, is the ratio of its opposite side to its adjacent side. So, when we get down to the root of what is tangent, tangent is an operation that mathematicians much smarter than ourselves have firmed up, concreted, and said, like, this always holds true no matter what. When given a ratio, I can do this thing and find out the angle. Vice versa, when given an angle, like degrees, I can do this thing and find out the leg lengths of a right triangle that it makes. So what it's comparing, if we take it back to our unit circle, is when I have some angle. We know the hypotenuse is 1. We know that there is some circle around here. I mean, if we pull the 1 to either of them, we can connect down there, connect down there. TOA is relating compared to the angle we're looking for, theta. What is your opposite? Like opposite from the angle, and what is your adjacent? Adjacent has to be right next to and touching. So that side touches the angle. The opposite side does not. It has no interaction with the angle that I'm looking for. So opposite is always across the triangle from our theta angle. Adjacent is always the side right next to it. That is not the hypotenuse. So although the hypotenuse is adjacent, it is not the adjacent, because it being the hypotenuse is more important than it being the adjacent. So that's what chooses which one gets to be the adjacent. They can't both. And of course, hypotenuse is across from your right angle. It is under. That's what hypo actually means, is under the right angle. So how do we apply this? If you know your leg lengths, how do I undo an operation? If I told you tangent is an operation, like how do you be careful saying opposite, inverse operation, right?
Yeah.
So what we're actually going to come to find out, and this is me teaching you more than I should today.
Why? Teach us.
Theta, the angle we're looking for, and then I'll get you guys out of here, is equal to, Richner doesn't care. When you struggle with your homework, I will play you a sad, sad tune on a tiny violin. The inverse of tangent. On the calculator, you hit second when you hit tangent. The little -1 means an inverse function of that ratio. Opposite over adjacent. And you will have the exact angle of elevation or whatever you're looking for. I should have just stopped myself. So we will talk about cosine and we will talk about sine, but we use tangent when I'm looking at the legs of the right triangle, just the legs. Hypotenuse doesn't come into play because in our slope or in our unit circle, hypotenuse is always 1. And this is what we actually refer back to. All right, I actually used all of your time today, so head on out to lunch. Have a wonderful day. We will pick this up tomorrow and try to blow your brain some more.
There are no words for how confused I am.
I mean, there's one word, trigonometry.
Okay.
You're physically confused.
So, I heard a long so.
Testing something.
Oh, it works.
I know.
Are you testing the 22?
I want
to see how close it is?
Know what to do.
So here, if we go back, so here I'm going to capture this, but if we go back to what we looked at today, right, like the 2 compared to 5, right, so we started with 1 compared to 5. Check out the 1 compared to 5. I should really make you go to lunch. But, so this triangle, our 1/5, try it with the opposite of 1 and the adjacent of 5. So do inverse tangent of 1 to 5.
Inverse tangent of 1/5.
Yeah, 1/5.
11.3.
So now do inverse tangent of 2/5. So the 1 being very close to 11, 11 was actually slightly less than it should have been. But it doesn't actually double, because I thought how angles actually work. Because it went twice the height doesn't mean it's actually twice the elevation. It's just twice the height. It's still the same distance. So it actually multiplies by a little bit less than 2, because we were over 11 and we were under 22. It's very close. They're negotiably close. Now, if we use some bigger numbers, we can get to much better relationships. So, like, I would challenge you. Could you find 2 integers that work better than 1 and 5 to get closer to 11? You know what I mean? Use bigger numbers. So, like, 2 and 10 wouldn't, like, it'd be the same thing, right? I'd get the same answer. So what about, like, 2 and 11? Or 2 and 9? You know, like, start playing with it. But you got to get to lunch. Sorry, I could talk about trig all day long. So trig is also the way that, like, say you were trying to figure out how far it was to get across a river, like we did, like we started to do on that one test with you guys. Trig is a way that you can figure that out. Or how tall is that tree? Like, how high is my frisbee stuck up in that tree? You can use trig to figure those things out.